Coming up on Coding 101, we start our embedded processor segments with Mark Smitty Smith.
Netcasts you love.
From people you trust. This is Twit.
Bandwidth for Coding 101 is provided by CacheFly at CacheFly.com.
This episode of Coding 101 is brought to you by Squarespace. Creating and editing your website is easier than ever using their redesigned interface, Squarespace 7, which includes integrations with Getty Images and Google Apps, new templates, and a developer platform. Try the new Squarespace at squarespace.com and enter the offer code C101 at checkout to get 10% off. And by HipChat. Collaborate, save time, and be more productive with your teams. HipChat is IM, video chat, plus file, code, and screen sharing all in one place. Invite your team members and get a free 30-day trial of the full version of HipChat at hipchat.com/C101. Welcome to Coding 101. It's the Twitch show where we let you into the wonderful world of the Code Monkey / Code Warrior. I'm Father Robert Ballecer, the digital Jesuit, and I'm joined by my super special guest co-host, Mr. Lou Maresca, a senior software lead for Microsoft. Lou, thank you very much for coming back onto the show.
Hey, thanks for having me, Padre. Appreciate it.
Now, we promised our audience something a while back, that we would take a look at embedded processors, specifically the programming that you would need to play with devices like the Arduino, or maybe even a propeller chipset, something that wasn't quite the conventional programming language that we had been playing with here on the show. And we're going to get to that, but before we do that, Lou, you've got some news about the Internet of Things.
Yeah, that's right. I mean, right now there's approximately 4.9 billion connected devices in use this year. And 1 in 5, they're saying basically 1 in 5 developers now work on IoT projects, which is pretty interesting if you think about it, from home automation to connected devices, to health devices, to wearables. And so we're looking at almost 19 million developers worldwide. And 19% of those are doing IoT related work. So that's a lot of people actually working on IoT devices if you think about it.
Now, Lou, hold on a second. You know, IoT is one of these things that has been a buzzword for probably the last 2 years. People are always saying, "Oh, it's about the Internet of Things and big data. We're now going to get data points from everything, from traffic signals, from home appliances, from your thermometer, your smoke detector." But I've seen something different, and maybe you've seen this too, which is it's not so much that there was a new field called Internet of Things and people started building Internet of things. It's that everything is now enabled to be part of the Internet of Things.
That's right. I think one of the biggest things is, what are they actually doing when they actually integrate these little devices into your world, into your life? And to me, I think it's really taking those devices and kind of where are you bringing that data? How are you merging that data together? That's really kind of the key to what Internet of Things are now today, is taking that big data and making sense out of it all.
Right. Now, I remember there was a Gartner study that was talking about how sensors in devices could result in 15% savings in just the food and beverage industry alone, which leads me to the question, where's the money here? So if you're a programmer, and remember, we've all talked about how money is not the reason why you get into programming. The passion for programming is why you get into programming. But that aside, if a programmer watching our show right now started saying, maybe I want to start doing IoT programming, where are the studies saying the money's going to be?
I mean, the biggest value today in IoT is definitely not necessarily the sensors, because you could put unlimited sensors together and be able to get data out of them. The key really is making sense out of the data. It's housing the data. The data itself, the services that wrap around the data is where the money is. So if you can have all these different sensors, especially around wearables, that you're pulling all this telemetry data from a person's body, what's useful for that? What are you going to do with that data? Are you just going to show them their heart rate? What's that going to do for them that they can't already do by just doing this, right? So I think that's kind of the key is those services wrapping those Internet of Things devices is really kind of where the value is and the value prop for that type of device.
The architect in the chat room is saying, "Oh, I only program for the dollar bills, yo." And that's a semi-joke, but you know, it's also kind of true, which is if you're going to learn a specialty, if you're going to carve out that niche, you kind of need to make sure it's going to be able to pay the bills. But here's something that I saw at CES, and again, I want your expert opinion on this. We saw a lot of companies that seem to be presenting on new services that maybe focus on the analytics of things instead of the Internet of Things. In other words, every company is doing an Internet of Thing enabled thing, smart bands and health bands and fitness bands and refrigerators and dryers. But it seems as if the real money, and maybe this is where the programmers can get an early leg up here, is taking the data that you actually get from those sensors and turning it into something usable. It's no longer enough just to say, this is on the Internet. It's now got to be, this is on the Internet, and this is the kind of data and the kind of forecasts that you can make.
Right, that's the key is forecasting, right? That's you're taking these models, you're training these models with this massive amounts of data coming in, and then you're forecasting, you're recognizing data that actually can give you forecasts. And so, like, for instance, you know, you're doing things like pattern recognition and anomaly detection where you're identifying things that are kind of out of bounds. You're again doing predictive maintenance. So like if you're detecting problems with, you know, a car or you know, detecting problems with your heart device, you know, optimization, how can you optimize things going forward? Prescriptive, you know, being able to get into situations and give things for people that they don't actually know they need. And of course, situational awareness. So like if you're in a situation and you don't see this over here, maybe a device can actually show you that you know, increase your vision, you know, that kind of thing. So that's really kind of where all these are coming from. But the key is where is that data going, and how is it actually making sense out of it all? So that's where the power lies in Internet of Things.
Lou, I'm glad that you found this story because this ties right in with the segment that we're going to be doing today. One of the things that Smitty brought up at the very start of his segment was that when you start looking at embedded programming, and actually you could say this, when you start looking at Internet of Things, it's not necessarily what I can do, it's about what problems do I have and then how am I going to solve them. We're going to get right into that. We're going to be jumping straight into this segment that we recorded with Mark Smith, where he's going to be talking about taking an Arduino and doing something interesting with it. But first, let's go ahead and take a break to thank the first sponsor of this episode of Coding 101. You know them. You love them. They're the fastest way to get online with your portfolio, with your work, with your blog, with whatever piece of retail business you want to bring to the Internet. It's Squarespace. Now, Squarespace is a one-stop shop for you to get onto the Internet. It's not only that they make it easy for you to put up content. It's not only that they've got beautiful templates for you to use. It's not only that they'll give you a free domain name if you buy your service for a year. It's the fact that it is so easy for you to put away the programming side and instead be very, very creative. Now, Squarespace 7 was recently launched. It's the latest version of their platform. It's a completely redesigned interface that makes it even easier to create your own professional website or online portfolio. I've used Squarespace a lot in the past because I deal a lot with organizations that don't have a programmer. They don't have a systems IT person. They've got someone who kind of knows computers and they need a way to have a presence on the Internet. Well, Squarespace is perfect for them. Now, here's some of the new things that you're going to get. Live editing on one screen. This is huge. If you've ever tried to make a change to a website and you've saved and then reloaded and then saved and then reloaded, those days are over. You get to make your changes in a clear, simple, and more intuitive way. With Squarespace 7, there's no more toggling between Site Manager and the preview mode. It just shows you as you make your changes. They've also got a developer platform that is used by some of the world's top digital agencies. If you're a developer, you can customize your site exactly the way that you want, which means that if you're a beginner, you can just get something up there and it'll look beautiful. But if you do have experience, if you do want to play with the code, you've got that option. They've got 14 new designs, which gives you over 30 to choose from, and Cover Pages is new with Squarespace 7. That's a way to choose from 10 new templates that can be added to any existing Squarespace site. It's perfect for creating quick landing pages and giving yourself just a little bit of uniqueness. You've also got access to Getty Images. If you've ever wondered whether or not you're going to get dinged for copyright, you don't have to anymore. For just $10 for each image, you can pick from thousands of professional Getty Images. They've enabled e-commerce for all subscription plan levels, which means you can easily add a storefront to any site and instantly accept payments. And they've got Google Docs integration, which works with Gmail, Google Docs, Sheets, Drive, and Calendar. Plus, Squarespace 7 can easily link branded email accounts to your domain. They've also got Portfolio, Note, Metric, and Blog mobile apps that let you make changes from anywhere and see how your website is performing. In other words, go anywhere, do anything, and keep an eye on your presence. It's easy to use, we all know that, but if you need help, they've always got live chat and email support 24 hours a day, 7 days a week, plus just a garden of self-help articles and video workshops to browse at your own leisure. It only starts at $8 a month, and Squarespace takes care of the hosting, so you don't have to. And here's what we want you to do. We want you to start a free 2-week trial with no credit card required and start building your website today. When you decide to sign up for Squarespace, make sure to use the offer code C101 to get 10% off and to show your support for Coding 101. To begin using Squarespace 7, existing customers can go to the Settings tab to activate all the new features. We thank Squarespace for their support of Coding 101. Squarespace, start here. Go anywhere. I'm standing here with Mark Smith, known as Smitty to the people from DEF CON. Now, Mark, again, we had you on the show before. It was for a wildcard interview, and you explained what you do at DEF CON. For the folks playing at home, could you tell them again, what's your involvement with I'd say, the coolest hacker conference on the planet?
Well, I spend most of my time in the Hardware Hacking Village working on various different projects. This past few years, I've been doing the DEF CON Darknet project, which is kind of inspired by Daemon and Freedom TM by Daniel Suarez, where one of the many projects that I did was I don't even know.
Well, you created the Darknet badges.
Okay, there we go.
Yeah, the idea was that you had these badges that people could solder together. It's a blur. I know.
It's a blur.
It
yeah.
really is. But once they created, and they had to create them because they came in their components. You had to solder these things together.
It was a learn to solder kit.
You could actually sync them together with people who offered knowledge. And so the idea was not only did they learn how to solder, learn how to load up an embedded device, but they also had to go and obtain knowledge in order to get points.
Yes.
Which is, it's basically, that's the plot of Daemon and Freedom, which is...
A lot of it.
Right, when we have these networks of people who interact with one another to gain experience, it's a better world. Now, you promised that you would come on the show and you would give us some embedded programming knowledge.
Okay.
And so that's what we're doing here today, right?
All right, yes.
Yeah. This seemingly beautiful clock in front of us is actually not any sort of standard clock at all. I'm not sure if our audience can see it, but these are actually 3 gauges. These are just standard gauges.
Analog panel meters.
Panel meters that take volts, and they tell you how many volts are coming in, how much power is coming into the meter. But you have repurposed this a little bit. It's no longer a standard clock. In fact, if we turn it around, I think the folks will be able to see that, that's just what? That's an Arduino.
That is an Arduino and a real-time clock and a few potentiometers and some wires.
And what does this do?
Well, it tells the time, just like a clock. So the whole point is that it is a microcontroller and it loads the time off the real-time clock, which is that board right there, that little blue board hanging off the top. And then the Arduino is programmed to output the correct analog voltage so that the meter reads the correct time.
Very cool. One of the phrases that it doesn't set me off, but it does make me wonder if people actually understand what they're talking about is when they say, "Oh, I'm gonna internet enable something," or I'm gonna add an Arduino to it, and it's gonna be an Internet of Things thing.
It's a buzzword.
It's a buzzword. But a lot of people don't understand how that actually works. You don't just slap an Arduino onto a refrigerator and suddenly it's an internet refrigerator. Can you tell me a little bit about what you need to do before you even pick up any hardware or do any embedded programming? What are the steps that you take to say, this is a project I can do and this is how I should do it?
So first and foremost, you have to know what it is you're trying to accomplish. You want to know what your inputs and outputs are, right? In this particular case, we're going to be taking the clock from the time from the real-time clock and turning it into an analog voltage to read on the panel meters. On a refrigerator, what are you going to be doing? What are you controlling with an Arduino? Are you going to be reading the temperature? Are you going to be storing that temperature? Are you going to send it to a computer to be graphed over time? You have to understand what it is you're trying to accomplish. You can't just slap an internet onto something and say, hey, look, it's IoT, and be done with it.
It's got an Ethernet cable coming to it. It must be enabled.
That's right, exactly. So you need to understand what it is you're trying to accomplish and then choose the right tools for that job. The job is not, I'm going to put the internet on it. The job is, I'm going to read this particular value and then perform some action. I'm going to take some inputs and I'm going to do some outputs, and I need to put the box in the middle that's going to convert those inputs into the right outputs.
It's interesting that you put it that way, because that's actually the methodology that we gave to our audience in talking about any sort of program.
Correct.
Anytime you want to program, you need to figure out, what is it that I have? What resources do I have? What do I want it to do? What kind of data can I take in, and what do I expect to push out?
Correct.
And unless you're doing those steps, unless you're actually thinking it through, then all you're doing is putting together a bunch of hardware that may or may not do what you want it to.
Exactly.
Yeah.
I mean, one of the things they taught us in computer science classes is that you can optimize, if you have a program that has no outputs, you can optimize it into a no-op.
Right.
It does nothing. If you have no output, all it is a bunch of input, and it doesn't do anything with it, you can perform all the computation you want, but if there's no output, there's no point in writing that program at all, right? So you need to have some sort of an output to have an effect on the world. That's what your ultimate goal is, right? To change the world in some way. And generally, those outputs require some inputs. Not all the time, but most of the time they have some sort of an input that goes into that.
Well, if it's going to be useful, it has to have an input. Otherwise, it's just doing the same thing over and over and over again.
Yeah.
You want something to be able to react to its environment, or react to the place that it's tied into, in order to do something useful. Now, in order for us to do that, we have to actually understand what kind of inputs we can get and what kind of functions we can get. Specifically, we're dealing with embedded processors. Now, we've got in front of us right now, these are some Arduinos?
Correct. This is an Arduino Uno. It's an R2, or it's one of the older versions. You can tell from all the dust on it. But it is an Arduino. And you'll note that the big chip here is an Atmega 328, ATmega, made by AVR, or Atmel. It is a normal, quote-unquote, standard microcontroller, but what the Arduino folks did is that they wrapped this board around it. They gave it a power supply, they gave it a programming port, and some standardized headers over here that made it very easy for other manufacturers to make what are called shields to go on top of them. Zoomed in just as makes these shields that go on top of them. And this is, for example, is a prototyping shield. So we can put components into the holes and run wires around as necessary to rig things up on kind of a temporary basis, try it, break it, realize, oh, that didn't work, pull it out, try something else, and go from there. And then when we're done, we can rig up something like that, where you actually hardwire all of the components in place in a point-to-point fashion, and it's still on top of an Arduino. You can still see an Arduino Uno underneath there, but it's much more permanent, and it's not going to, the wires aren't going to fall out like they would on the breadboard.
This sort of programming, these sort of chips have been around forever, for a long time, and there's many different platforms. Each are good at something, or a few things. But what Arduino did, Arduino actually took all that stuff and it put it into an easy-to-use package, so people could actually start to learn embedded programming. Now, for comparison, this is one of the quadcopters that I built. So this is a 450 class. This is actually, you can't see it, but inside here, this is a flight controller that's actually using an Atmega. It's an Atmel chip that allows me to upload a sketch. So if you learn Arduino programming, you learn the programming that you need to do things like the multi-Wii controller.
Correct.
Which all it does is it takes inputs. It takes inputs from its sensors. It knows these kinds of pitches. It has a barometer, and this actually has an input for a GPS. So it can take that input, and then I can use that in my sketch to say, if the angle is thus, increase the thrust on this side so it levels out, and so on.
Exactly.
That's exactly what you do when you want to try to program an embedded processor. It's really not that complicated as long as you know from the beginning what are my inputs and what do I want it to do.
That's exactly right.
There we go. All right. So let's go a little bit deeper. Now we know what this is, and ultimately we want to show the folks at home how to be able to
make one of those.
Something like this. We've talked a little bit about what I need. So I need to know what my inputs are. I need to know what my outputs are. I now know what we're going to be playing with. We're going to be playing with the Atmega chip from Atmel. What do they need to do when they're looking around? Because there's going to be people out there who say, this is the module I wanted. What do I need to buy and have before I start programming next week?
You're going to need the Arduino itself. The Arduino, there are lots of different flavors of Arduino, Unos, Leonardos, Duos, Megas, all kinds of things. And they all have different features and inputs and outputs. And so you want to find one that is capable of doing whatever it is you're trying to accomplish without being over-spec'd. You don't want to have too much, because then you're just spending a lot of money on things and a lot of power budget on things that you don't necessarily need.
When you say over-spec'd, what are the differences between like an Arduino, a Leonardo, et cetera, et cetera?
The Leonardo and Unos are actually very similar. The main difference is in the I/O, the USB I/O.
Okay.
On the Leonardo, the USB is built into the main processor, which lets you do things like, I'm going to write a sketch that makes my Arduino look like a USB keyboard or a USB mouse. You can actually talk on the USB bus from your sketch. The Uno doesn't do that. The Uno just has a serial port out to actually another processor that converts it into USB, and so it's only a USB serial port. But some of the other ones have much more differences, like the Mega is a much bigger board. It's got a lot more inputs, a lot more outputs. It has more memory, I believe. I think it's one of the 128s instead of the 32s. So it's a bigger processor. It's got just more of a lot of the same stuff. So you kind of want to size your microcontroller for the project that you're doing. In my case, I am reading from a real-time clock. I'm doing a very little bit of math, and I'm turning it into an analog output. So as long as the main Arduino has 3 analog outputs, which it does, it actually has 6, and it has the ability to read from an I2C bus, which it does, to read from the clock, then it serves my needs for this clock. That's all we needed for this one. So I was able to use some of the smaller and cheaper Arduinos.
Right. In the next episode, we're actually going to be giving people a sketch that they can load up onto an Arduino to make it do something.
Correct.
But right now, could you show them what the interface looks like? Because there's an IDE, a developer environment for this chip, for Arduino, for this platform. What does it look like? And could you just run us through some of the things that we could start playing with before the next episode?
Sure. So the Arduino IDE stands for Integrated Development Environment. That was something that I didn't learn until it was my 2nd or 3rd year in college, so I wanted to get that out there in case I didn't want to assume people knew what that is. It's an integrated development environment. Basically, it is a text editor, like what we have on screen here, combined with a compiler. And in this case, also because we need to upload our final product onto a chunk of hardware, it also includes the code uploader. So what I have on screen here is just the Blink code that comes with Arduino. It's very simple code. It has a setup function and a loop function, which are the 2 default Arduino wrapper program or functions that you need to write. And all it does is it sets a pin mode 13 to output, and we'll go over in more detail what all of this means.
Right.
And then it does that in the setup, which runs once. And then in the loop, all it does is it sets pin 13 high, then it delays for 1,000 milliseconds, just waits. Then it sets it to low and delays for another 1,000 milliseconds. And then, as the name of the function implies, it loops. It goes around and around and around and does the loop function over and over and over again.
Now, we've covered loops in several different languages here on
Correct.
Coding 101, and I'm sure my audience right now is looking at that loop and saying, wait a minute, there's no condition that this thing would never stop, right? It's just going to keep looping and looping and looping.
Correct. So the way Arduino does its code is that there are 2 functions that always have to be in an Arduino sketch: setup and loop. Setup gets executed once at the very beginning when the device first powers on, and then it calls loop. And when loop exits, it calls loop again. And when loop exit, it calls loop again. And it just continues to loop over and over and over again. So that is the basic structure of an Arduino sketch. You can also write loops inside the loop function to do your own looping for whatever you want. But the way the Arduino works is it just does the same thing over and over and over again.
Which is what you want it to do, because it's not a multi-purpose processor.
Correct.
It's an embedded processor. You want it to always be looking at the same instructions.
Yes.
Otherwise, it would run once and then just
sit there
until you
exactly.
reboot it, until you power cycled it.
Yeah.
So if I am writing in a sketch, it's always going to have those 2 parts.
Correct.
If I ever write a sketch that doesn't have those 2 parts, it just plain off.
I don't think
won't
it'll
work.
even compile.
It won't even compile.
Yeah.
Right. Okay. Now this, if you go back to that screen, Brian, this is a wonderfully simple piece of code. In fact, this reminds me of some of the code that we would get on the DEF CON badges. Like the ones that we could actually program, and we could start changing the LEDs.
The main badges, not the darknet badges.
No, that's right. Not
Yes.
the darknet, not the darknet badges. Now, when you look through this, What are some of the features of the programming, aside from the fact that there's two parts, there's the setup and the loop, that you think people should start to be aware of? So you've got digital write, you've got delay, and digital write again. Why is digital write there? What does that do?
So one of the things that separates embedded programming from programming that you would do on a normal computer, on like a full-size computer, is that you are interfacing to hardware. And so you need to have, if you are developing an environment like that, like the Arduino folks did, you need to be able to make it easy for the programmers to interface with that hardware. So rather than go into all of the assembly nitty-gritty to flip the bit, the output pin on the device and do all that stuff, they just wrapped it up in a function. And it's called digital write. Digital write means write this value to this pin. So this line here is literally taking the digital pin called 13, and if you look at the Arduino, they are numbered, and we are setting it to high, which means put a high voltage on it. In this case, either 3.3 or 5 volts. I'm not sure which one this is, but it's a high voltage on it. Otherwise, if you write digital write low, it'll bring it down to ground. It'll bring it down to 0 volts. And so it's a very simple way of affecting the real world. What this program is meant to do is it's meant to blink an LED on and off. On for 1 second, off for 1 second, on for 1 second, off for 1 second, lather, rinse, repeat. It just goes on and on like that. And so it's a very simple demonstration of how do I make my code change something in the real world.
All right. One of the other features here that we should probably talk a little bit about is it doesn't just have to be on or off.
Correct.
You can actually do more with the pin, which is vital if you're going to do something like the clock, because of course this clock has way more values than you have pins.
0 and 1, exactly.
Exactly. So you have to have some way of saying set it for X value plus something, X value plus something, and just keep going up and
Correct.
up and up. We don't want to get too much into the clock already, but there is another feature about this, which
Absolutely.
is this doesn't give you high voltage. This is not going to give me enough power to do something like a gauge, which is why you would need something like a Proto Shield, because you're going to have to add components to turn your programming into usable output.
Correct. So in this case, actually, you went the other direction. The meters are current devices.
Right.
Even when they are measuring voltage, they are current devices. So the actual mechanism, that coil right there, is measuring how much current is being sent through that wire. It doesn't care about the voltage across the wire. And then they add extra components inside the meters to turn a voltage into a current to make it gauge correctly.
So right now, you can see with the Arduino is actually increasing the amount of current on seconds
Correct.
in order to make it match up with the numbers on the display. So it actually shows you seconds.
Correct.
Yeah, I'm not sure if people realize this is actually working right now.
Right now. I mean, you can see the seconds moving because they're pretty easy to see. If you look closely at minutes, which we probably don't have enough resolution to do here, minutes actually ticks up by every 15 seconds. Without getting into too much detail, there are 240 ticks on each one of the meters. And so the minute hand goes by 1 tick every 15 seconds, every quarter of a minute.
Right. Let's talk a little bit about this proto board.
Okay.
Because this is something that I think a lot of people are going to want to do, because
Yeah.
you want to be able to add components, remove components without doing a lot of soldering.
Correct.
When I first started with electronics, this was the thing. I had a breadboard.
Yep.
I would put LEDs, I would put jumpers between the LEDs and components, and just to figure out what that component did. Oh, that's what a capacitor did. Yep. Oh, that's why you use a timing crystal. Show me what a typical assembly would look like. We've got some components here. What would I put on this board in order to make it start working with my Arduino?
Well, so we have a proto board here. I don't have any circuits in mind, but let's go ahead and hook up, my hand's in the wrong way. Let's go ahead and hook up a potentiometer. So that is what's called a 10-turn, or in this case, a 25-turn potentiometer. It's just an adjustable resistor.
Right.
So this one is a 10K, so I can turn the little screw head on the top and make it any value between 0 ohms and 10,000 ohms.
Exactly.
Okay, and then we have these wires that with little hard pins on them, and you can just plug that into any one of the outputs of the Arduino and then plug it into a hole on the board.
Yeah, it's the same row.
That one doesn't actually have one.
There we go.
So something to note about these proto boards, The way they work, they just look like a sea of holes. But if you were to plug in a wire in that hole in the very corner over there, and then plug in a wire in that hole there, and on the other end, each one of these rows is all connected. So all the holes on that row are connected. All the holes on the next row are connected to each other, and so on all the way down. And then on this side as well, they're connected separately. The idea is that you can put a chip across the kind of the gap in the middle, and you'll be able to get access to all of the pins on either side. So that's why we had to hook up the potentiometer this way so that I can get access to all of the pins, because there are 3 pins on the potentiometer.
Because if you turn it sideways, they're actually on the same. They're all on the same line.
Exactly, they're all in the same row. That you just shorted all 3 of the pins together, which doesn't help you a whole lot. So that's how the breadboards work. You can plug components into the breadboard, and then you can plug jumper wires between pins on the components and make a very simple circuit very quickly, very easily, without having to do any soldering, without having to fab any boards or do any circuit layouts or anything like that. It's very quick iteration. You can experiment and figure out what works. And then once you have a circuit that you know works, then you can solder it and make it more permanent and be done.
Smitty, in just a second, I'm going to ask you to give people a preview of what we're going to be doing over the next 3 episodes of Coding 101. But something that we heard from Steve Gibson. Steve Gibson came on the show, and he gave us a little bit of assembly. I know that
I'm a fan.
You're a fan of Steve Gibson.
I'm a fan of Steve's.
And one of the things that he told us was, look, this is about foundational knowledge. We understand that you could go out and you could buy something that could tell you the time a lot better than this. You could go out and you could buy things that would do most of the functions that you might create with an Arduino, but you don't get the knowledge. You don't understand the underlying workings of the things that you're using. So what kind of advice would you want to give to someone who's going to buy one of these kits? They're going out, in fact, right now they're going over to Amazon.com, they're looking for Arduino, they're finding the Uno, they're finding the proto board, and they're getting it shipped to them overnight so that they can have it for next week's episode.
Yep.
What do you want them to play with between now and next week when you're actually going to show them how to program it?
What do I want them to play with? Well, the Arduino IDE comes with a lot of good sample code. Looking into those would be a good option. And just think about what problem they have in their life that they might want to solve, that they think something like this would solve for them.
That's excellent.
So that's where all of my projects come from. It's not I want to play with an Arduino, what should I do with it, right? It's, this one's a bit gratuitous because this one is more of a...
It's pretty. It's eye bling. We get it. Okay.
It's an art thing. Yeah. But I'll give you another example. My fish tank aquarium controller. I have a 55-gallon aquarium at home, and I wanted to be able to control the lights and give my fish actually sunrise and sunset at sunrise and sunset. Again, it's a little bit gratuitous, but it's one of those things that I thought that I could do. And so the input would be, what time is it? And then the math, the work that the controller would actually do would be to calculate what time sunrise is and what time sunset is on any given day. And then the outputs would be, all right, I'm going to output an analog voltage, and I will have to amplify it. I will have to have a board that turns a small voltage from an Arduino into a large voltage for the LED lighting in the fish tank to slowly ramp the lights up on the east coast, on the east side of the tank, and then slowly ramp up the lights on the west side of the tank. And then, of course, it went overboard from there, and I have red lights for sunset and for dawn and dusk, and I got a blue light for moonlight.
Isn't that how it normally happens?
It just goes overboard.
It just starts ballooning. You're like, well, you know what? If I'm going to do this, I should probably have different colored lights.
I've got 6 analog outputs, and I'm only using 2. What can I do with the other 4? Yeah, so the advice I would give is to figure out something in your life that you wish you could do, some problem that you have, or even if it's not a problem, just some sort of an artistic, neat, nerdy, awesome, crafty thing, whatever it is that you want to do, and figure out and start thinking about what are the inputs and what are the outputs. And chances are, if you can enumerate what those are, there will either already be modules that can do that for you, or you can research that one particular thing, and there will be some instructional tidbit on the internet that shows you how to do that one particular thing.
Mark Smith, thank you very much for coming on. Thank you for being our code warrior for the next couple of episodes.
Awesome.
Could you tease tease the audience with what they're going to see next week. So we're assuming that they're going to get all the hardware that they need. We're assuming that they've loaded the IDE on their platform. By the way, it will work Linux, Mac, PC, so
all of them.
Doesn't matter. Get it working. What will they be doing come next week?
So there's my tease.
Every language needs to start with Hello World.
Every language needs to start with Hello World. If nothing else, it proves that you know how to compile and build and put onto the platform and all that fun stuff.
And believe it or not, it's not very far from what you're seeing right now to this finished product, because this gives you all the information you need. It gives us a way to get stuff into the Arduino,
Correct.
a way to get stuff out, our outputs from the Arduino, and it's showing us that it can count the clock. So that's all we need.
That's it.
There we go. So look for the show notes, because they're going to have links to all the components that you need to buy if you want to follow along. In fact, if you don't want to build this, in fact, if you took Smitty's advice and you just figured out something that you want to do in your life, something that you need, that's fine. And all of the lessons that you're going to learn for this module will help you, because it will show you how to program the Arduino. But if you do want to build yourself a really snappy clock, then go ahead and buy all those components on the show notes, and we're going to show you how they work.
All right.
All right. Until next time, that's Mark Smith. He's been our code warrior, and back to me in the studio. We want to thank Mark Smith for dropping the knowledge about embedded programming on us. He's going to be coming back for 3 more segments where we're going to talk about how you take the Arduino and turn it into something useful. Now, don't forget that you can follow him on his Twitter account. In fact, it is the way to find out what he's doing. Just go to twitter.com/SmittyHalibut. That's right, just like it sounds, SmittyHalibut. Don't ask why he's called that. Unless you're at DEF CON, go ahead and go up to him, ask him why we call him Smitty. Now, we will be getting back to some of our discussion about embedded programming, but before we do that, let's take a moment to thank the second sponsor of this episode of Coding 101. Now, we are a tech agency, so of course we talk a lot about communications. In fact, in the shows that I do, Coding 101 and Know-How and This Week in Enterprise Tech, I'm every week bringing up new tools, new suites that people have developed to be able to communicate better. But even in a world of email and chat and 15 different types of telecommunications, we sometimes need a type of communication that's set up exactly for business. And that's why we've got HipChat. HipChat is a way to communicate that is for the modern business, a way that gives you not just the ways of sending your email and your IMs and your text and connecting your video chats, but also a way to look back through time to figure out what the genesis of an idea was. Anyone who's been in business will tell you that that's worth its weight in gold. Now, how is your team communicating? Are they using a variety of email, IM, texting, cloud storage, and document sharing apps? Well, why? HipChat puts everything in one place, and it's designed for your business. HipChat is an IM, a video chat, a document sharing, screen sharing, system update, and code sharing system integrated into one simple platform. Email is too slow. Meetings get sidetracked, and regular IM doesn't work well for groups. But HipChat keeps your team in sync, and it works from any device, no matter where you are. The best part, HipChat integrates with the top developer tools like GitHub, Jira, Zendesk, and more. You can check out the 57 services that HipChat plays nice with. HipChat brings your entire project and team communications together so that you'll never lose that vital piece of information that you need to move forward. Best of all, it's easy to set up, it's fun to use, and it makes your team widely productive. We use HipChat here in the Twit Brick House, and it is the best way to book guests, to talk about what our future topics are going to be with, to bring all of our hosts and our co-hosts, everyone here in the Brick House and out of the Brick House, so that we're on the same page. You need something like this because it doesn't just let you communicate, it lets you be productive. So here's what we want you to do. We want you to get your team on the same page in seconds. There's a freemium version that you can use free forever, but for the next 30 days, you'll get the full version of HipChat, which includes the bonus features of video and screen sharing. You can try HipChat free, no credit card required. Visit hipchat.com/C101. Sign up, click on Start Chatting, then invite a few team members and try it free for 30 days. And for the first 100 signups, HipChat is going to extend their free 30-day offer to 90 days. That's right. Remember, hipchat.com/C101. hipchat.com/C101. And we thank HipChat for their support of Coding 101. Now, Lou, what did you think about that? I mean, embedded processing. Smitty was all about explaining that it's not necessarily about the hardware, although we love focusing on the hardware. It's about that idea of finding something you want to do, finding a problem you want to fix, figuring out your inputs and your outputs, and then, only then, starting to spec out the hardware that you're going to need.
Super powerful stuff if you think about it. I mean, if you know what the devices that you need and you find a way to hook them together, they become, you know, just an aggregate of a system that can control a lot more things and do a lot more things that you actually could do by yourself. So that's where the power of IoT devices come from, and it's some awesome stuff. Looking forward to next week.
And that's really the difference between a lame IoT device and a good IoT device. A lame IoT device is, here's something that we added a chip so we can connect it to the internet. A good IoT device is something where you said, you know what, this would be better if we had visibility into it over the internet. That's why we should make it. And I think that's something that Mark Smitty really gets. Now, really quickly, I want to run through some of the parts that Smitty suggested that you get. So if you want to follow along, if you want to go step by step and build your own clock, because that's what we're going to be creating, here are the parts you're going to need. And Zach, if you could pull up these links as we go. The first one is an Arduino Uno. Now, this one you can find on Amazon just by typing in Arduino Uno, and you're going to find it for about $24.95. It's a fantastic little device, very easy to use. You can get a lot of clones out there, but I would really suggest that you try to get an authentic one, because some of the clones have issues with some versions of Windows, and you're not going to want to get one that gets bricked. The second thing is a Proto Shield, and Zach, we have, again, links for all of these. You're going to find this at solarrobotics.com. This was the device that Smitty showed you that goes on top of the Arduino. It's a shield that plugs into the pins on the side, which will allow you to extend the capabilities of the board. It allows you to solder in new components, new resistors, etc. The third thing is the RTC, the real-time clock. You absolutely need this if you're going to be doing the clock. We're going to explain why in the next episode, but if you jump over to this, you can, again, get this from Amazon. It's not that much. It's $6.99. It's free shipping. And then you're also going to need some potentiometers, some 10K potentiometers. Get this over at Amazon. Again, it's not going to cost you that much. Now, here's something Smitty and I talked about. You could buy 5 of them for $5.43, or you could buy like 100 of them for, you know, $30. So if you're going to be doing a lot of these projects in the future, consider getting a larger pack. And the last bit that you're going to need are the analog volt panel meters. Again, you can buy these from Amazon. We're making it easy for you to get them. But if you live near a halted supply store or a surplus supply store, often you can get some much nicer looking ones. Smitty was a big fan of the Aviator ones, the rounded dials. But those are going to cost you between $3 and $10 a pop, depending on what style you like. Altogether, this project is going to cost you just under $70, and that's including the shipping. So yeah, if you want to follow along, that's a really good way to do it. If you want to cheap out, you could get a clone knockoff Arduino and a knockoff Proto Shield, and you could probably drop $10, $20 off the price of the project. But I'd say go authentic. Lou, what do you think? Is this a project that you might want to play with?
Definitely. And I would say definitely stay authentic, because this way you get better tool support, and you kind of know where the compiler comes from and ID and all that stuff. So I'd stay with the kind of the authentic stuff.
Right. One last bit before we go. If you could go ahead and show my overhead, Zach. These are some of the devices that I use on a daily basis. These are all embedded processors. So this is a KK 2.15 flight controller. These are both multi-Wii flight controllers that I use. And this was actually the badge. This is the conference badge from DEF CON 2 years ago. These are using Atmel chips. This one is using a propeller chipset, but these are all embedded. And so whenever I create a custom firmware for my flight controllers, I use this USB controller to tie straight into the serial port, the I2C on each of these boards, and it allows me to reprogram the firmware. Now, this obviously has a very dedicated use, but the nice thing is the wisdom that Smitty is going to be dropping on you is the same wisdom you'd be using to program any of these. So embedded programming, it's not just for geeks anymore. Oh, next time we're going to be going into the actual programming. We're going to be showing you how to assemble some of the hardware, and Smitty is going to explain why you need a real-time clock. But until then, I want to thank my super special guest co-host, Mr. Lou Maresca, again, a senior software lead from Microsoft. Lou, where can they go if they want to find out more about you and your work?
Sure, yes. Always find me on Twitter, LouMM, L-O-U-M-M. And of course, about me, LouMM as well. And all of my work during my day job is found at crm.dynamics.com.
Fantastic. And you'll be here next week to help spread the knowledge to all the good boys and girls. Until then, there's some information that we need to let you know. We know that this is a lot of information, and we want to make it easy for you to follow us along in the project. So we're going to make sure that in our show notes, we're going to have links to all the places where you can buy the individual pieces, as well as where you get to download the Arduino IDE and a few helpful hint sites. So if you want to move ahead in the class, you can go ahead and do that. But in order to get that information, you have to drop by our show notes page, which you can find at twit.tv/code or coding or coding 101. They all go to the same place. If you go there, you'll find our entire back catalog of episodes, which is important because it will let you download entire modules. If you want to learn what we did in C# or in Perl or PHP, it's all right there. It also gives you a place where you could use that little drop-down menu to get every episode of Coding 101 automatically downloaded into your device of choice. That's right, if you want it in your iPhone, in your Android tablet, in your Mac, your PC, your laptop, your desktop, we make it easy because we love you. Also, don't forget that we do this show live every week. Right now, we're doing it on Thursdays at 1:30 p.m. Pacific time. Starting in March, we're going to be moving to 2:30 p.m. Pacific time on Mondays. But you can join us at live.twit.tv. And as long as you're watching live, why not jump into our chat room at irc.twit.tv. I'm going to say a few things about live, but I'm going to save that for the next episode, I think. I just realized I don't want to say it right now. Until next time, he's Lou Maresca. I'm Father Robert Ballecer. End of line.